Hi everyone. I'm Barbara Alimisis. I currently work as a power system manager in UK in one of the major UK distribution network operators. And as part of the things I do is I design the future network of England and considering renewables as part of the solutions when it comes to generation. And while most people think of Peru, the first thing that comes to mind is Machu Picchu or Lima or the amazing food. What is lesser known is that Peru has one of the lowest electrification rates in the developed world. So this is particularly true for the rural areas, where it is estimated that up to 70% of the population has unreliable access or no access at all to electricity. So in 2016, I spent 6 months in North Peru. North Peru is the poorest part of the country. It was through Engineers Without Borders, and I was doing work for a Peruvian NGO called Wind Aid. And I worked together with volunteers from all over the world to build wind turbines and install microgrids for such community. The driver and the mode at the same time was to light up a life, deliver clean renewable energy, and empower the local communities. The easier way to think about it is to start by thinking a fan that we use on the hot summer days, right? So the fan uses electricity to make wind. Wind turbines do the exact opposite. They use wind, that's the movement, to make electricity. So wind flows over the blades, creating lift, which causes the blades to turn. And the blades are connected to a drive shaft that turns an electric generator. And that then produces electricity, what is needed to power our houses, our commercial buildings, whatever this might be. So Peru has an excellent wind potential. A vast majority of the population lives across the coast, so this is particularly true there. But at the same time, we're looking to develop microgrids with cheap solutions that we could construct locally, source materials locally, and drive the cost down. So wind turbines were particularly favorable if you compare them, for example, to photovoltaics, where you would have to import most of the solution, and this would drive costs up. And even for the local community, it's more of a mechanical system, so it's easier to troubleshoot with little knowledge and more intuition as compared to other renewable alternatives. The key challenge really was how to source materials locally, and also how do you build it with when you have scarce materials, you don't have an equipped lab, and then how do you transport it where it is needed, which might be a remote location, right? And some parts of the wind turbine, like the blades, are quite big. And how do you assemble the solution once you reach the local community, because you wouldn't have a lab there either. The other challenge was working with local underprivileged communities, how to communicate, how to gain their trust, considering that rarely anyone gives you something for free, right? And how also to train them so that in the end they have ownership over the project post installation, and they're in position to, if it stops working one day, knowing what to do or whom to reach for help. So volunteers from several parts of the world came up with a simple design that could be produced with basic tools and mostly locally sourced low-cost materials. And the design was being perfected year by year. We didn't start from scratch. So we have come up with a design that wasn't particularly big, and could work for the local communities, something like 270 kilowatts, something that could power local school and the community center. And we were doing most of the building in a main city of Peru, and then we were transporting the main parts to the communities that needed it and doing the assembly there. Together with local people, they were very, very eager to help. For transporting the parts, at times we had to just be very creative, use paddling boats, all sorts of solutions. Not necessarily. So someone who understands physics could do the same, but you needed someone that could improve a design. You equally needed, working hands in a way. So you needed people to build the blade, sound the blade, paint the blade. And it was a matter of having some people that knew how to improve a design, knew how to test an installation, but equally having people that had a willingness to just help, get their hands dirty and learn across the way. Says things that you read in books and people keep talking about, how powerful electrical engineering can be, what impact it can have, but seeing it firsthand, it was quite remarkable to understand the social and environmental impact electrical engineering can have, and how easy it truly is to use science to improve the lives of others, which we often forget. Most certainly can. And if you see what is happening all around the world in all developed economies, to start with, wind turbines, their share into the electric generation mix gets higher and higher. But what is also important to note is that wind turbines on their own cannot achieve the net zero target, so bring zero carbon emissions to an equivalent of zero. Because wind has a stochastic nature, right? However, wind turbines together with batteries, they can form solutions that can deliver reliable electricity. And this is the best way forward, marrying solutions with clean energy to reduce our footprint while delivering reliable electricity. Climate change action calls for reduction or displacement of fossil fuels-based generation. So renewable energy generation is crucial to that end, but we should not forget at the same time changes in our behavior as end consumers of electricity.